Hello, hello, and this is 8.1 number 1. Now, for this problem, we're going to try to find your volume. Now, Archimedes did this by putting himself into a bucket of water. So if this was a big beaker of water, where I don't have a blue marker, blue marker. If this was a big beaker of water, I would just simply put you in here, and we'd measure how much the water level rose. And that would tell you the volume. However, I can't do that in my classroom, so we have to come up with a new method. So we're going to use our formula for density. Density, that's a rho by the way, is equal to mass over volume. Now, since I cannot figure out what the volume is, I'm going to cheat. The average density of a human body is between 945, if you're really obese, 945 kilograms per meter square or meter cubed, to 1,020 kilograms per meter cubed. So it's somewhere between 945 kilogram meters per meters cubed to 1020 kilograms per meters cubed. Now, most people, when you say, okay, you're really obese, they would think the number, 1020 would be bigger, but that's actually not true. Fat floats. Fat is not very dense. So if you're fatter, you're actually towards the slope to the lower end, not at the higher end. So I'm going to say, probably could be working out more. I'm going to put myself down as 995. So my density is 995 kilograms per meter cubed. Now, this is a guess, but unfortunately sometimes you're limited in what you can do in a classroom. So I'm going to put this down. You come up with your own density. It doesn't have to be mine. And by the way, if you're thinking, oh, I'll just make it what Merritt's is, that'll make things easier. No, it won't, because your mass will not be what mine is. So we're trying to find that volume, okay? Now, one thing you could do, multiply this by volume, multiply this side, so multiply both sides by volume, and you get 995 kg meters cubed. V times V is equal to, these cancel, 108.9 kg. Divide both sides by 995 kg meters cubed. 995 kg meters cubed. So that cancels, and you get that the volume is equal to, now in my case, it was equal to 0.109. Now that's a very small number, it's less than 1. And a lot of people are just like, wait a second, how could this number be so small? Bear with me. The kilograms cancel. And on the denominator of a denominator is the same as the numerator, so it's meters cubed. Now that's not liters. Don't think of like a 1 liter soda bottle or something. It's like, how could it be less than that? This is not liters, this is meters cubed. That is, imagine a box, 1 meter by 1 meter by 1 meter. That's a very large box. 1 meter by 1 meter by 1 meter. I do intend to build one. Is that a box that I could get into? I'd have to sit down, but I could sit in that box and still have a lot of room in there. And just about anybody else could. And I'm a big guy. I'm a very big guy. So the fact that I could sit in that box and have plenty of room, I wouldn't be able to stretch out, but there'd be a lot of space in there. You could stick pillows in there. I could have my chicken in there. Not that I'd want to be in a box with a chicken. There's a lot of space in there. So the fact that I get this number, 0.1, I still, the box is still 89% empty. So I'm not filling up that box. Now, if you want to find out what that is in liters, 1 cubic meter is 1,000 liters. So I simply multiply this by 1,000, and I would get volume is equal to, 109 liters if I want to find the volume. So when you look at it in terms of liters, it actually is quite a bit. But anyway, by the way, if you're not as big as me, your numbers are probably going to be smaller than mine. So I suspect that most of you are going to have a much smaller number for volume. Thank you very much. Have a nice day.